Hello all. In this video we're going to dig into the basic built-in Python data types. So we'll talk a little bit about what each data type is, how we write that data type in Python, and what are the operations and functions that you let us manipulate that kind of data. This is a foundational tool that we need in order to write programs that do almost anything. So we're going to start, as I said before, with this big idea. We organize information inside the computer into data types. Data types are different from each other because we need to be able to do different things with the data depending on what it means out there in the real world. So every data type has three different aspects to it or components to it that are important to keep in mind. The first one is that there is some sort of internal representation inside the computer for what that data type, how that data type is represented in the computer. We don't necessarily need to know all of those details, although sometimes it's good to know because sometimes it makes a difference in how we can work most efficiently with the data. But by and large, we don't have to know what the internal representation of our data is. Not for now. Secondly, we have the visible representation. That's like how the data looks when we refer to it in our programs, how the data looks when the computer prints that values for us that are of that data type. So that can be different and is separate from the internal representation. The internal representation is just how the computer itself represents it, but it's going to show it to us in a more readable form, usually. The third element that all data types have is a set of operations of different sorts that let us manipulate that data. The operations tend to come in several different forms. There are operators, and these are things like if you're talking about numbers and we want to do arithmetic, plus sign, minus sign, those kinds of symbols that mean some sort of an operation. We have quite a few of those for all of the data types that we're going to look at. There are also functions that we'll see as we go forward. These are named. So you have a name and you call the function and you pass it the data and it does something with it. There are lots of built-in functions that operate on the data that we're going to be looking at. The third one is methods, and for right now we're not really going to look at methods, but most of these data types do have methods as well. That's a slightly different kind of function, and we'll talk about it a little bit down the line. We don't need those for today. Before we jump into talking about data types, there are a few basics for programming in Python that are really important to understand. So these are, again, programming building blocks. Even the examples we've done so far, I've kind of assumed that you would make sense out of these building blocks, but now we really want to talk about them carefully. So the first thing is a set of terminology. These are technical terms we use when we talk about a programming language. They're used almost regardless of what programming language you're talking about. There's this idea of something being a statement or being an expression. Sometimes they're both. So a statement in a programming language is a complete instruction that performs some task or causes some change. So we've seen examples, we've seen print statements. When we print something, the effect of it is to cause some text to appear on the screen for us to read. That's a statement. It's a complete instruction by itself. Assigning a variable to a value, and we haven't talked in detail about variables and values, but we've seen some examples. That is another kind of a statement. You can also, we're going to learn about asking the user to input something. That's another kind of a statement because we usually combine that with making an assignment. We store what the user types into a variable. An expression is a piece of code that evaluates to a value. Now, there are lots of expressions, and you can put expressions together with other expressions to build bigger expressions, but what's key about them is that they evaluate to a value as opposed to being an instruction that causes a change. So basic data that we've already seen are in fact expressions. So a number all by itself is an expression because by itself it evaluates to its own value. The number 32 has the value 32. The string ABC, as you see in the notes here, that has the value of a string containing the characters A, B, and C. It is its own value in some sense. But we also have expressions when we are operating on the data and producing a new number or a new string. So I have a couple of other examples right here. One is just doing an arithmetic expression, assuming that we know what x is and z, maybe from what we have up above, we would evaluate this expression and it would turn into a single number. We also have a function there. That's one of the built-in functions that operates on numbers. Max. Actually, it'll operate on any of the data types we have. Max returns the largest value that you pass it. So again, this is an expression because it is doing something. It's figuring out which is the largest value, but it basically turns into that value. It evaluates to be the largest value that is passed to it. And the input function by itself, if you don't pair it up with an assignment to a variable, that input function is in fact an expression. It returns a value, or it turns into a value. So we'll keep seeing this terminology. Just start to make friends with it because it's an important distinction in a lot of programming languages, is when you are writing a statement versus when you're writing an expression. All right, I want to focus in a little more on variables. So oftentimes when you're first learning programming, you look for other instances where you've run across variables, and you may have seen them in math classes. And the idea of a variable in computer science draws on that concept of a variable in math, but there are some differences in practical terms in how these things work. They come down to the fact that in math, we're often interested in statements of truth, what is true about a particular situation that we see. And in computer science, we're interested in calculations. We want to calculate something. So that gives us, we think about variables just a little bit differently than you might in mathematics. But in a lot of ways, it's very similar. So here in bold letters is in fact a key definition for what a variable is. A variable is a name that is attached to a memory location, and we can store data in that memory location and therefore store it in that variable. So it doesn't have to have a fixed value, and this is where it gets different than how we usually use variables in mathematics. If I tell you that x equals 3, that means x equals 3 for now until the end of the problem. But that's not the case in computer science. If I say x equals 3, I mean x equals 3 for now, but I can change it at any point if I wish. So variables have varying value even within a program, within one problem. I like these pictures. This is the picture on the left, I think, is actually an old card catalog, but you get the idea. It's a piece of furniture with lots and lots of little drawers, each one of which has some sort of a label attached to it. And the picture on the right is a sort of typical mailboxes in a mailroom. Each one has a number associated with it. They're each individual locations where things can be stored. This is a really good metaphor for how to think about variables in computer science. So imagine that I have a variable x, and it actually corresponds to, say, the box on the right there, box 174. X is the name we put on that box. It's the key that lets us find that box and access the data that's inside of it. We can assign at least one, possibly more than one, variable name to refer to the same box. But fundamentally, it's a reference to a bin in which we store data. Okay, I have one more big idea, and then I'm going to pause, and we'll come back in another video and talk about operations on numbers. So the other piece that was mentioned earlier that you may or may not be that familiar with is the notion of a function. So again, functions are things that you see in math class all the time. Functions in computer science are similar, but again, not exactly the same. So there, I put here a picture of a mathematical function. F of x comma y equals 3x plus 2y. We could actually turn that into very good Python code without we'd have to make some changes to it, but fundamentally we could make a function that acts just like this one is described. You give it a value and it would produce the value of 3x plus 2y. But we can do a lot more things with functions. So what is a function? Well, we've seen some already. We've seen things like print. We've seen int, maybe. I might have called int at some point or another, or it was in your readings for sure. Float, stir. We're going to see a lot more functions as this material goes on, because we use functions to manipulate data. What are they really? A function is a named set of statements that perform some task. Now you remember in an earlier video we talked about an algorithm. A function is an instantiation of an algorithm. It's a representation of an algorithm. Functions can take 0 up to any number of inputs. Things like print will take any number. Other functions that we call may not take any, or they may take 1 or exactly 2 or something like that. But they take some number of inputs, which is the data that we want them to operate on. And they do something with that data. They can cause side effects. That means they can print values, they can pop up windows, they can write things to your hard drive. They can return values as well. And sometimes in some of the readings that you have, they may make a distinction between fruitful functions, being the ones that return values, and non-fruitful functions being the ones that cause some other effect, like popping up a window or printing a message. They're still all functions. It's just whether they have that return idea in them, where a value comes back out of the function. So function calls, when we actually call a function and ask it to do its thing, they could be either expressions or statements. The print, when you call the print function, that is a statement. But the input function, when we call that is an expression. We have some terminology around this. We're going to talk more about this when you start writing your own functions. But for right now, we refer to the values that you pass to a function as the arguments or input parameters. And you can put any kind of Python expression you want into a function, as complicated as you want it to be. These are some really big ideas. It's a lot of terminology. You get better at doing these things through practice. So I don't want to belabor this, but it is important that you have a good sense of these underlying terms and what they might mean, and you'll get a fuller idea of how these operate as you actually work with them.